parabola of the whole topic. So we start off with how to sketch this parabola x squared plus bx plus c. So the first thing we do is find the something, y-intercept. And how do we find y-intercept? Substituting, very good, x equal to 0. Once we find the y-intercept, we find the x-intercept by substituting y equal to 0. These are important features of the graph. You must show this on the graph each time. And to find the x-intercept, usually we do have to factorize, but sometimes already factorized for you. Then you don't have to do much. And then use the null factor law to find the answers. Next, we're going to find axis of symmetry. And the axis symmetry can be found also the x-coordinate of the turning point, which lies something between the x-axis, halfway. All right, very good. And then after we find the axis symmetry, we substitute the x-coordinate into the rule to find the y value of the turning point. So substitute the x value of the axis symmetry. Actually, not x value. Substitute. That should be substitute. Substitute. Okay. Right. Right. So that's a summary. So let me get a highlighter. So make sure you highlight this. The box. Okay. Once we do that, we can then look at an example. We're going to sketch this. So what's the first step? Let's find the y-intercept. That's the easiest one to find, which is -12. X is 0. Y equal to 0 minus 0 minus 12, which is -12. That's your y-intercept. So you will label it there at some stage. And then we're going to find the x-intercept. And to find the x-intercept, we'll put in y equal to 0. So you put 0 equal to x squared, which you have to factorize. And then use the null factor law to find out the x values. Okay, so what do? We're going to write x minus 6, x plus 2. And then you get x equals to 6 or -2. Alright, so we've got these features, so we're going to label them. So you've got 6 here, got -2 there, got -12, of course not to scale. What you need to find is what we call the axis of symmetry, the halfway mark. And that can be easily done by using the formula average the two x-intercept, which is equal to 2. So that's your axis of symmetry, halfway between the x-intercept. Once you do that, you must substitute 2 back into the original formula to get the vertex. So let's substitute x equal to 2, and the rule is y equal to 2 squared minus 4 times 2 minus 12. That using your calculator, 4 minus 8, -4, -16. So that will be your vertex, which is lower than your y-intercept over here, 2, -16. Yep. So we've got these points, and then we can join them to form a parabola. So let's join them using a freehand, not very well drawn. If you use a pencil, that will help you. Okay, that's your parabola, passing through the x-intercept, the y-intercept, and the vertex, passing through the axis of symmetry. Okay, let's make this a little bit neater. So we put the 6 so you can see the 6, and that's a -2. So edit this, -2, and then put the lines in. All right, done. Okay, so hopefully you got that. Parabola drawn. So very easy. Y-intercept, x-intercept, halfway mark, axis of symmetry, substitute, get the point, the vertex. All got it? Okay. All right. I think there's another example. We'll have to look at another form. Okay, we'll go through this. Make sure you finish that. Hope you all got it. Let me see. I just need to have a quickly look at what we're going to do next. Got this. Okay, good. All right. Nice. Okay. Now, there's another form of the parabola that you should also know, which is the perfect square form. Okay. Going back to here. When the parabola is written this way, you can find the vertex first. So when it's this way, find vertex first. because that tells you the shift. The h is the vertical shift, and that's the horizontal shift. And because you know which way it goes, you can work out the vertex first. And the A tells you whether it is concave up or concave down. It is negative. Okay? I think that's all. So then we're going to do an example. Okay? Right. Write this down. Okay, hopefully you're all ready. So we're going to look at this. So basically the -1, remember, is to shift right 1 unit, and the -3 is down 3 units. And due to this fact, your vertex is 1 and -3. That's your vertex. Okay? So you work out the vertex first. And once you get the vertex, you can almost sketch it immediately. 1 -3 is here, 1 across, 3 down, 1 -3. You can almost sketch it, like if I use this pen, which will delete itself. So you can just sketch it straight away like that, right? But then you want to find out the x-intercept and the y-intercept, okay? So that's what we're going to do. So to do that, we're going to follow the same procedure as before. Okay, so let's find the y and x-intercept. Let's start off with y-intercept. And that's when x is 0. And when you put 0 into x, you get 0, y equal to 0 minus 1 squared minus 3. Using your calculator, you will get 1 minus 3, negative 2. So now you know it crosses the y-axis at negative 2. Pass through this point. And in addition, you have to find the x-intercept. That's when y equal to 0. Okay? When you put 0 into y, you get x minus 1 squared minus 3. And remember, you do not need to expand. A faster way is to just move the 3 to the other side. And it's already a perfect square form. And after you move the 3 on the other side, you just have to square root. So you don't have to expand and factorize, just square root. Plus or minus, like that. And once you do that, you can move the negative 1 to the left. So you get x is 1 plus or minus root 3. Which tells you that there's 2 x-intercept. One is 1 plus root 3. The 1 plus is on the right. And the other one is 1 minus root 3. Okay, so cross through these 2 points. And the y-intercept and the x-axis. So and after that, yeah, because the vertex is found, you don't need to find the axisymmetry. It's already done there. That's your axisymmetry. So we're going to draw it like this. And maybe that dot is too far on the left. Actually move this thing. That's good. Okay, we got it. Any questions? So it's very easy. So remember these 2 different things. Remember clearly. When you see this, work out the vertex first. When you see this, find the y and x-intercept first. Remember 2 cases for parabola. Okay. All right. Any questions? Maybe, oh, I pressed the wrong one. Okay, good. Okay, let's continue. All right, let's go to the next page. And we've got more stuff to write down. We also did discriminant. Let's look at the symbol for discriminant. So the symbol for discriminant is the triangle. The name for that is delta. In Greek, it's a Greek letter. And the formula for discriminant is b squared minus 4ac, the stuff inside the square root. And why do we need to know discriminant? Because it tells you if the discriminant is positive, it tells you there are 2 x-intercept. And if this discriminant is 0, it means 1 x-intercept. And if the discriminant is negative, it means no x-intercept. So it's quite useful. It tells you whether parabola will have 2x-intercept, or no intercept, or 1 intercept, just by calculating the discriminant. Okay, I'll write it down. And the further use of the discriminant is that we can look at whether the lines will intersect the parabola, as you learned in exercise 9G. So it is possible for a line to meet a parabola. Okay, I just try to think what to write in here. Meet a parabola once, twice, or not intersect. I don't know why there's 3 ways, but anyway. So either meet a parabola at 1 point, 2 point, meet a parabola twice, or once, or none. I forgot. Okay, just write either meet twice, once, or none. And I'm going to illustrate that. So a line can cross 2 times, or a line could just touch us at 1 point, or a line does just miss the parabola entirely. Okay, which are to do with the discriminant. So if the discriminant will be positive for this case, discriminant will be 0 in this case, discriminant will be negative in that case. So that's another use of the discriminant, finding out whether the line will cross or not cross, or touches the parabola at 1 point. And there's a special name for this. When it crosses at 2 points, the line is called a secant. And when it touches at 1 point, the line is called a tangent. And when it doesn't intersect, doesn't have a name, just a line. Okay? Let me write it again. Tangent. Tangent. Okay, good. So to find a point section, to determine another solution. Okay, very good. Okay, let's look at some examples. All right. Okay, all right, good. Let me just stop this. Thank you. All right, let's continue. So how do I find out where the line crosses the parabola? You do so by solving simultaneously. So to find a point intersection of the line, solve simultaneously. And how do we solve simultaneously? We can do so by substitution. So in that case, I could substitute, maybe I put this one into here. Right, so that means this y are now replaced by x squared plus 3x minus 1 equal to x minus 2. So we'll make them equal to each other. Move all terms to the left, which is plus 2x plus 1. Yes, if you factorize, you get this, which is a perfect square, not 1, negative 1. And how do I find out where they intersect? Sub it back into the original. Y equal to x minus 2, replace the x by negative 1. So therefore, it's equal to negative 1 minus 2, which gives you negative 3. That's the point of intersection. And because it crosses once, it is a tangent to the parabola. Okay, like this. Okay, so therefore, because it has one solution, one point of intersection, one point of intersection, shorthand, one point of intersection, therefore it's a tangent to the parabola. Therefore, line is a tangent to parabola. Okay, done. If it crosses at 2 points, it is a secant to the parabola. Oh, it's the same question, isn't it? But this one asks how many solutions. Oh, actually, I'll leave it there because you're still writing. I will talk about this. Okay, I need to say something. Let's continue. Okay, now it's the same question, but this question asks determine the number of solutions. How many times would the line cross the parabola? And when they say how many times they cross, they really just want you to just solve them simultaneously. Equal to x minus 2. Move it all to one side. And then after that, do not solve it. You find the discriminant. And the discriminant is 2 squared minus 4ac, right? Which is equal to 0. And when you get 0, you conclude, therefore, lines touch parabola. I mean, not lines. Line touch the parabola at one point. At one point. Like that. So, which is really corresponding to this case, right? The tangent, 0, corresponding to this case. Yep. So it really depends on what the questions say. If the questions say, find a point in section, solve them simultaneously, find x and y. If they say how many solution, how many, just find the discriminant, right? Okay, now to illustrate to you what does it look like for this question, so it looks like cos at -1, -3. So therefore, this line here, if I draw it, let's draw this. So this line here, y equal to x minus 2, touches at one point. So it looks like that. So -1, -3, right? And that's the line. This is y equal to x minus 2, and the equation of the parabola is y equal to 3x, x squared plus 3x plus 3x minus 1. Okay? So that's what it will look like visually when you draw it. All done. So we've seen the application of parabola, the connection of lines in 3 different cases, and also know how to sketch parabola. Okay, so make sure you learn how to use this and do the work. Okay, so today you do the chapter review. I don't think you only do half of the chapter review, so look at the unit work to see what you have to do. Review.